Welcome to the introduction. So we are today going to discuss about one of the very famous algorithm under the supervised machine learning technique called as KNN, which stands for K nearest neighbor. Let us just explore what the KNN is. So as I said, KNN comes under the category of supervised classification algorithm. So let us first try to understand what do we mean by supervised, what do we mean by classification, and what do we mean by machine learning algorithm. So machine learning is basically a process using which we try to provide ample of data as well as algorithms to the machine. Machine, with the help of the algorithm and the data, tries to train itself and will uncover a lot of the things that are very difficult for us to just to view into the data. So machine will discover those patterns. Machine will discover those relationships among the data elements that we are having, which we can use for the further predictions in the future. So there are various ways in which machine learning can be implemented using supervised, unsupervised, semi-supervised, and reinforcement. In supervised machine learning, we are provided with input as well as with the output. So for example, if you are predicting whether the person would be a defaulter or not, then the past record or the historical information of all the bank customers will be given along with their status of making default and non-default. Along with that, you will have the variables such as their ages, their gender, their any previous debts they have, or any loan they have taken, their income, their co-applicants' income, their number of dependents, the number of years they are living at the same address, and so on. So all this information is nothing but input information, and your output information is whether the person was actually made default in past or not. Once you get this information, you try to find out a relationship in between all this input variable and your output variable. Once that relationship is established, you can use that for your future in order to predict that given an age or given a gender or given a kind of number of dependents and all the other information, are we able to find out that whether the person would be defaulted in future or not. So that's basically what the supervised machine learning algorithms are all about. So what is KNN now? KNN is again a classification algorithm. So here my dependent variable is going to be categorical in nature. What do we mean by categorical dependent variable? The one which is having only discrete possible outcomes. For example, in the given case that we are discussing, that whether a person is defaulted or not, you'll be having only two possible set of outcomes, that is yes or no. Similarly, if you are discussing the case related to the employee in the HR kind of domain, that whether a person would be a churner or not, again, that's a kind of what you can say categorical data. Or you're having the different species of the plants and provided the values of sepal length, sepal width, petal width, you have to identify that whether it belongs to species A or B or C. Again, this is called as a classification only. So KNN is basically a supervised and classification type of algorithm that we can use for the classification of the data elements in future, that is for the prediction. So now let's try to divide this word KNN. So K stands for how many nearest elements that you want to consider. KNN basically stands for K nearest neighbor, where the value of K is generally considered to be square root of the total number of observations provided in the data. We can use it for the classification as well as for the imputation, and few times KNN is also used for regression as well. So in that case, in that exceptional case, your dependent variable will be numeric in nature. KNN is a distance-based measure. That means in order to find out the class of a particular observation, you need to find out its distance from all the given observations in the data set. And in order to find out a distance, you can use the Euclidean distance formula, which goes as under the square root of x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square, so on up to n1 minus n2 square. So that depends on how many column information you have in your data. So in order to find out this distance, obviously you need to have numerical quantities, and that's why for KNN, it is compulsory that your independent variables or input variables must be numeric in nature. Your output variable is majorly categorical. Sometimes it can be regression, KNN regression, so the dependent variable can be numeric as well. But majorly, dependent variable is classification variable or categorical variable only. It's one of the simplest algorithm in the machine learning category, which is very easy to learn, which is very easy to adapt, which is very easy to implement as well as to understand. But it's a lazy learner. That means KNN requires a lot of time in order to process and provide the final outcomes to the user. So this is a simple diagram that will help you to understand what KNN is actually doing and how it is doing. So basically, suppose you are provided with these two classes. The first is a class of squares and the another one is a class of triangles. So you can find out that there comes a new observation, which is unknown observation represented by that diamond kind of shape. And you have to identify that whether it should be classified as green squares or whether it should be classified as a red triangle. So that's nothing but a question in front of you. So how will we solve this question or how will we solve this problem using KNN? So you have to find out the distance of that given unknown point with respect to all known points in your data. Once you identify the distance, you have to decide the value of k, which is generally considered to be square root of total number of observations. So suppose say the value of k is 3 in this case, let us just assume it, or 4 in this case, or let me just assume that the number of points are 25. So the square root will become 5. So I'll consider 5 nearest observations. So this might be the first nearest observation, this might be the second, this might be third, fourth, and fifth. So I have this 5 neighbors for this particular given unknown observation. Out of 5, 2 neighbors are suggesting that the observation should be a rectangle, but my 3 neighbors are suggesting that the observation should be classified as a triangle. So I'll go with the maximum vote, and as the maximum vote is towards a triangle, I will classify the given observation as triangle. This is basically how KNN works in reality. So for example, you have been provided with data of the name of customer, their age, their income, their number of cards, and a response that whether they are ready to purchase the next card or the another card or not. So you're having this all information with you, and suppose this is the new customer that comes with the name David, having the age 37, income 50,000, number of cards already having are 2, and you have to predict that whether this person will take up a new card or not. So what you will do is you'll try to find out a distance of David's observation from all the other observations that are provided in this data. So the first observation would be square root of 37 minus 35 square plus 50 minus 35 square plus 2 minus 3 square. That will provide you the first distance, that is a distance in between the observation David and John. Next, you'll find out a distance in between the observation of David and Rachel. So suppose that is under the square root of 37 minus 22 square plus 50 minus 50 square plus 2 minus 2 square. So that will be the second distance. Then you'll find out a distance of David with Ruth, that is the square root of 37 minus 63 square plus 50 minus 200 square plus 2 minus 1 square. Whatever is the answer, that is noted as 152 and so on. Once you get all these distances, you will try to find out the least distance among all the distance. Suppose the value of k you are considering as 1, then you are interested to find out only one nearest example. So the nearest example you can see is 15, that is with respect to Rachel, which is saying that the class should be no. So here the prediction will be no. If you are considering the value of k as 2, then you'll find out two nearest distances. So that is nothing but John and Rachel. Now in this case, John and Rachel are having 1 vote for yes and no respectively. So now you don't have any maximum vote as such. So in this case, we'll try to find out the minimum distance of David's example with respect to John and Rachel, and that is with respect to again Rachel, and so your response will be no. If you consider the value of k is equal to 3, as it is mentioned in the given problem, you'll try to find out three nearest distances, that is with respect to John, Rachel, and the last one is Neil. Now, in this case, you are having two responses of yes and one response for the no. So, as per the concept of maximum vote, the value of response will be given as yes only. This is basically how KNN works. So, the choice of k is generally considered to be square root of total number of observations. I hope you understood how the KNN algorithm works. In case of KNN regression, instead of maximum vote, it simply takes up the average value of all the other values that you're having in your data set. So for example, in this case, suppose your response variable is numerical in nature, then you'll find out the average of all those k neighbors, and that is going to be the predicted value for the given observation. So this is basically how the KNN works. I just hope you understood the implementation of KNN. Thank you for patiently listening to this video. In the next video, we'll definitely talk about some of the more interesting and exciting algorithms of the machine learning. Till the time, stay tuned. Thank you.